Hello and welcome to the second video on differentiation. Today we'll be looking at the quotient rule of differentiation. Last time we saw the product rule, which was for the product of two functions. Today we'll be looking at the quotient rule, which applies to the division of two functions. So if we have two functions of a variable, say x, and we take their quotient, what is the derivative of this quotient is what we want to find. So firstly, I'm just going to write down the answer. Okay, so this is what we are going to prove today, and then we'll also see a couple of examples. So okay, let me erase this. I'm going to start by rearranging what we have a little bit. So we have d by dx, the first function, and I'm going to write it as a product with the second function raised to the power minus 1, because as you know, anything a to the power minus 1 is basically equal to 1 upon a. So I can write the function, I can write 1 upon g as g to the power minus 1. Now to this I'm going to apply the product rule which we saw last time. So if you haven't seen the video, I'll put a link to it right now, so you can first watch the video and then see this proof. So if we apply the product rule to this, we obtain the following. So if you remember, the product rule is the first function multiplied by the derivative of the second plus the second function multiplied by the derivative of the first. So this I can rewrite as f, and now we'll be using the chain rule of differentiation to evaluate this particular part. So basically, the derivative of g to the power minus 1, we can first treat it as a normal polynomial. So we have minus 1 times g, and then we subtract 1 from minus 1, so that's minus 2, and into the derivative of g. So this is the chain rule here. So altogether we have minus 1 upon g square times the derivative of g with respect to x. Okay, and remember that minus 2 just means 1 upon g square. So this I can rewrite as multiplied by 1 upon g square multiplied by the derivative of g, and this I can write as 1 upon g multiplied by the derivative of f. Now what I'm going to do with this whole thing is, of course, first I can just simplify this a little bit. So this is minus f upon g square times the derivative of g with respect to x plus 1 upon g times the derivative of f with respect to x. Now what I'm going to do is I'm going to multiply this entire thing with g square upon g square. So basically this is just equal to 1, so it's like multiplying the whole thing with 1, but I write 1 as g square upon g square, as you'll see why. Now this upper g square, I'm going to move it into the bracket. So we have minus f upon g square multiplied by g square times the derivative of g plus 1 upon g into g square times the derivative of f with respect to x, and I still have this 1 upon g square outside. Okay, so this was the last step which we had derived. I'm going to continue writing on top. So we can simplify this a little bit. As you see, g square cancels off with g square, and here I can cancel 1g. So what I'm left with is minus f times the derivative of g plus g times the derivative of f, and this entire thing multiplied by 1 upon g square. Now I can rewrite the following, as since this is addition, I can switch the two terms. So I get g times the derivative of f with respect to x minus f times the derivative of g with respect to x. And of course, since this is multiplied by 1 upon g square, I can divide this entire thing by g square. And if you remember, this is exactly the formula I had written down in the beginning. So the way you should remember this is as follows. If you want to take the derivative of the quotient of two functions, so the easy way to remember this, okay, so let me just rewrite this. Okay, so if you want to take the derivative of two functions, the quotient, you can remember this formula quite easily without having to memorize where's the minus, where's the plus, which derivative, by the following expression. So if you call this upper function, since it's on top, we call it high, and say this one is low. So this one is down, so it's low, and the f is high. Then you can remember this thing by saying that the derivative is equal to low d high minus high d low upon low square. So that's a pretty easy phrase to remember. So what that means is low, you can write it as follows: low d high minus high d low upon low square. Okay, so low d high minus high d low, and low is of course just d. D high of course means the derivative of the higher function, so f, minus high, which is f, d low, which is the derivative of g, upon low square, which is g. So keep in mind this phrase, low d high minus high d low upon low square, and you'll easily be able to remember this formula. Now we'll see a couple of examples. Okay, so here we have a simple example. I want to find the derivative of the quotient of sine x and x. So I'm going to write it, of course, as low d high, so the derivative of sine x, minus high d low upon low square. So that's equal to x, the derivative of sine x is cosine of x, minus sine x, and the derivative of x is of course just 1 with respect to x, upon x square. So I can just simplify this as x times cos x minus sine x upon x square. This is what the derivative evaluates to. So this was a pretty simple example. Now let's look at a slightly more complex example. So here I want to find the derivative of the tangent of x, and there's no simple way of finding this formula except if you realize that what the tangent of x actually is just sine of x upon cos of x. So this is actually what the tangent of x is. And now of course we have a quotient, so I can evaluate this as low d high minus high d low, and don't forget upon low square, so that's cos square x. This is of course cos x. The derivative of sine x with respect to x is also cos x, so cos x into cos x minus sine x, and the derivative of cos x with respect to x is minus sine x upon cos square x. So this is of course equal to cos square x minus and minus, I can write it as plus, so plus sine square x upon cos square x. And now we have the most important trigonometric identity, cos square x plus sine square x, that's just equal to 1. So we have 1 upon cos square x. 1 upon cos square x, I can rewrite it as 1 upon cos x, the whole square, because 1 square is just 1, and cos square I can write it like this, and that will be equal to, okay, so maybe I'll write it slightly lower. 1 upon cos x is of course secant of x, so sec x, and the whole square. So you must have seen the formula before, that the derivative of tan x is sec square x, and so this is how you can go about deriving it. If you enjoyed this video, don't forget to subscribe, also like the video and share it with friends. I'll see you in the next one.